This video will be a continuation of our look at evaluating limits algebraically. And we're still on the very first topic of evaluating limits algebraically, and that is direct substitution. All we do is we take the limiting value, we plug it into the expression, to the limit expression, and see what value we get back. If we get a value back, a real number back, then that's the limit. If we get something undefined, then we have to do further analysis on it. So that works with polynomial functions, with rational functions, with radical functions, and it also works with, in this case, trigonometric functions. So let's look at number 27. Limit as x approaches pi over 2 of sine of x. All you need to do is plug in pi over 2 for x. Sine of pi over 2 is 1. And I will give you my strategy for memorizing the important trig values in the first quadrant. The first thing we're going to do is write out the numbers, write out the important angles. Pi over 6, even before that we'll start with 0. Then pi over 6, pi over 4, working our way through the first quadrant on the unit circle from 0 to pi over 2. Next we have pi over 3, and finally pi over 2. Following this, we're going to write sine, cosine, and finally tangent. Then the way we complete the table is we write in the numbers 0, 1, 2, 3, 4. So that's easy to remember. Then we're going to square root everything. And then finally we're going to divide everything by 2. And now all we have to do is simplify those values. Square root of 0 over 2 is just 0. Square root of 1 over 2 is 1/2. Square root of 2 over 2 stays. Square root of 3 over 2 stays. Square root of 4 is 2 over 2 is 1. And those are the important sine values in the first quadrant. For the cosines, all we need to do is flip that list around. So we start from 1, square root of 3 over 2, square root of 2 over 2, and then 1/2 and 0. Finally, to find tangent, since tangent is sine over cosine, all we need to do is divide down. 0 over 1 is 0. 1/2 divided by root 3 over 2 is 1 over square root of 3, rationalized, gives us root 3 over 3. Then root 2 over 2 divided by root 2 over 2 is 1. Root 3 over 2 divided by 1/2 is just root 3. And 1 over 0 is undefined. So you can use these values to start from. You have all of your important sine, cosine, and tangent values in the first quadrant. To find the secant, we just take the reciprocal of sine. To find the cosecant, we take the reciprocal of sine. To find secant, we take the reciprocal of cosine. Cotangent, we take the reciprocal of cotangent. And so that gives you the 6 important values, or the 5 important values for each of the 6 trigonometric functions in the first quadrant. So we'll apply those right now. Limit as x, number 29. Limit as x approaches 1 of cosine of pi x over 3. We're just going to plug in the 1 for x. Cosine of pi over 3, 1/2. Limit as x approaches 0 of secant of 2x. So that's 1 over cosine of 2x. 2 times 0 is 0. Cosine of 0 is 1. 1 over 1 is 1. And I'll just write those steps out so that you can see how that unfolded. Next, sine of 5 pi over 6. Limit as x approaches 5 pi over 6 of sine x. Sine of 5 pi over 6 is the same angle as the same value as sine of pi over 6. And so that's 1/2. Whenever the y value is positive, the sign will be positive. And since pi over 6 is still in the second quadrant, 5 pi over 6 is in the second quadrant, its value will be positive. Limit as x approaches 3 of tangent of pi x over 4. And that would be the same as tangent of 3 pi over 4. Tangent of 3 pi over 4 has the same value as tangent of pi over 4, which is 1. Then you want to remember the ASTC, all students take calculus. In the first quadrant, all trig functions are positive. In the second quadrant, the sine and its reciprocal cosecant are positive. In the third quadrant, tangent and its reciprocal cotangent are positive. In the fourth, cosine and its reciprocal secant are positive. So 3 pi over 4 is in the second quadrant, so that'll be negative. And that does it for this collection of problems.